A year ago, OpenAI unveiled ChatGPT, and it's really sparked a revolution that has totally reshaped the technology landscape. In this just short amount of time, AI hasn't just progressed, it's actually exploded. The year has shown us that AI isn't just a cool new thing, it's actually the future of computing. And at AMD, when we think about it, we actually view AI as the single most transformational technology over the last 50 years. Maybe the only thing that has been close has been the introduction of the internet. But what's different about AI is that the adoption rate is just much, much faster. Although so much has happened, the truth is, right now, we're just at the very beginning of the AI era. It requires a significant investment in new infrastructure, and that's to enable training and all of the inference that's needed. And that market is just huge. A year ago, when we were thinking about AI, we estimated the data center AI accelerator market would grow approximately 50% annually over the next few years, from something like $30 billion in 2023 to more than $150 billion in 2027. And that felt like a big number. We're now expecting that the data center accelerator TAM will grow more than 70% annually over the next 4 years to over $400 billion in 2027. So does that sound exciting for us as an industry? Our AI strategy is really centered around 3 big strategic priorities. We must deliver a broad portfolio of very performant, energy-efficient GPUs, CPUs, and adaptive computing solutions for AI training and inference. We have so much to share with you today. I'd like to get started. And of course, let's start with the cloud. Generative AI is the most demanding data center workload ever. It requires tens of thousands of accelerators to train and refine models with billions of parameters. And that same infrastructure is also needed to answer the millions of queries from everyone around the world to these smart models. And it's very simple. The more compute you have, the more capable the model, the faster the answers are generated. And the GPU is at the center of this generative AI world. And right now, the availability and capability of GPU compute is the single most important driver of AI adoption. So that's why I'm so excited today to launch our Instinct MI300X. It's the highest performance accelerator in the world for generative AI. MI300X is actually built on our new CDNA3 data center architecture, and it's optimized for performance and power efficiency. CDNA3 has a lot of new features. It combines a new compute engine. It supports sparsity, the latest data formats, including FP8. It has industry-leading memory capacity and bandwidth, and we're going to talk a lot about memory today. And it's built on the most advanced process technologies and 3D packaging. So if you compare it to our previous generation, which frankly was also very good, CDNA3 actually delivers more than 3 times higher performance for key AI data types like FP16 and BF16, and a nearly 7 times increase in int8 performance. So if you look underneath it, how do we get MI300X? It's actually 153 billion transistors across a dozen 5-nanometer and 6-nanometer chiplets. It uses the most advanced packaging in the world. And if you take a look at how we put it together, it's actually pretty amazing. We start with 4 I/O die in the base layer. And what we have on the I/O dies are 256 megabytes of infinity cache and all of the next-gen I/O that you need. And then we stack 8 CDNA3 accelerator chiplets, or XCDs, on top of the I/O die. And that's where we deliver 1.3 petaflops of FP16 and 2.6 petaflops of FP8 performance. And that supports up to 17 terabytes per second of bandwidth. And of course, to take advantage of all of this compute, we connect 8 stacks of HBM3 for a total of 192 gigabytes of memory at 5.3 terabytes per second of bandwidth. That's a lot of stuff on that chip. I have to say, it's truly the most advanced product we've ever built, and it is the most advanced AI accelerator in the industry. Now, let's talk about some of the performance and why it's so great. For generative AI, memory capacity and bandwidth are really important for performance. If you look at MI300X, we made a very conscious decision to add more flexibility, more memory capacity, and more bandwidth And what that translates to is 2.4 times more memory capacity and 1.6 times more memory bandwidth than the competition. Now, when you run things like lower precision data types that are widely used in LLMs, the new CDNA3 compute units and memory density actually enable MI300X to deliver 1.3 times more teraflops of FP8 and FP16 performance than the competition. Now, these are good numbers, but what's more important is how things look in real-world inference workloads. For something like Flash Attention 2 kernels, MI300X actually delivers up to 1.2 times better performance than the competition. And if you look at something like the Llama 2 70B LLM, and we're going to use this a lot throughout the show, MI300X again delivers up to 1.2 times more performance. And what this means is the performance at the kernel level actually directly translates into faster results when running LLMs on a single MI300X accelerator. But we also know, we talked about these models getting so large, so what's really important is how that AI performance scales when you go to the platform level and beyond. So let's take a look at how MI300X scales. Let's start first with training. When you look at something like the 30 billion parameter model from Databricks, MPT LLM, you can see here that the training performance for MI300X is actually equal to the competition. And that means it's actually a very competitive training platform today. But when you turn to the inference performance of MI300X, this is where our performance really shines. And what we see in this case is a single server with 8 MI300X accelerators is substantially faster than the competition, 1.4 to 1.6x. So these are pretty big numbers here. And what this performance does is it just directly translates into a better user experience. When you ask the model something, you'd like it to come back faster, especially as the responses get more complicated. That gives you a view of the performance of MI300X. Now, excited as we are about the performance, we are even more excited about the work we're doing with our partners. So here to tell us more about that is Microsoft's Chief Technology Officer, Kevin Scott. Kevin, it is so great to see you. What I admire so much is just your vision, Satya's vision about where AI is going in the industry. We're super excited for this moment. Now, I know you guys just had Ignite recently, and Satya previewed some of the stuff you're doing with 300X, but can you share that with our audience?
It is almost a year to the day since the launch of ChatGPT, which I think is perhaps most people's first contact with this new wave of generative AI. But the thing that allowed Microsoft and OpenAI to do this was just a deep amount of infrastructure work that we've been investing in for a very long while. One of the things that we realized fairly early in our journey is just how important compute was going to be and just how important it is to think about the sort of full systems optimization. So the work that we've been doing with you all has been not just about figuring out like what the silicon architecture looks like, but also just doing all of that software work that needs to be done to make this thing usable by all of the developers of the world. We're super enthusiastic about 300X. Satya announced that the MI300X were going to be available in Azure. Like, it's really exciting right now, sort of seeing the bring up of GPT-4 on MI300X, seeing the performance of Llama 2, like getting it rolled into production. And the thing that I'm excited to hear today is we will have the MI300X VMs in preview available today.
Kevin, we're so honored to be Microsoft's partner in AI. We look forward to a lot more progress.
Yeah, likewise.
Thank you
very much.
Here. All right, so look, we certainly do learn a tremendous amount every day, and we're always pushing the envelope. Let me show you the most powerful Gen AI computer in the world. Now, those of you who follow our shows know that I'm usually holding up a chip, but we've shown you the MI300X chip already, so we thought it would be important to show you just what it means to do generative AI at a system level. What you see here is 8 MI300X GPUs, and they're connected by our high-performance Infinity Fabric in an OCP-compliant design, which is the majority of AI systems today. And we did this for a very deliberate reason. We want to make this as easy as possible for customers to adopt, so you can take out your other board and put in the MI300X Instinct platform. And if you take a look at the specifications, we actually support all of the same connectivity and networking capabilities of our competition. PCI Gen 5, support for 400 gig Ethernet, that 896 gigabytes per second of total system bandwidth. But all of that is with 2.4 times more memory and 1.3 times more compute server than the competition. So that's really why we call it the most powerful Gen AI system in the world. Now, I've talked about some of the performance in AI workloads, but I want to give you just a little bit more color on that. When you look at deploying servers at scale, it's not just about performance. Our customers are also trying to optimize power, space, CapEx, and OpEx. And that's where you see some really nice benefits of our platform. When you compare our Instinct platform to the competition, I've already showed you that we deliver comparable training performance and significantly higher inference performance. But in addition, what that memory capacity and bandwidth gives us is that customers can actually either run more models, if you're running multiple models on a given server, or you can run larger models on that same server. In the case where you're running multiple different models on a single server, the Instinct platform can run twice as many models for both training and inference than the competition. And on the other side, if what you're doing is trying to run very large models, you'd like to fit them on as few GPUs as possible. With the FP16 data format, you can run twice the number of LLMs on a single MI300X server compared to our competition. And this directly translates into lower CapEx, and especially if you don't have enough GPUs. Now, as important as the hardware is, software actually is what drives adoption. So let me now welcome to the stage AMD President Victor Peng to talk about our software and ecosystem progress.
Thank you, and good morning, everyone. Now, today I'm going to focus on ROCm and the expanded ecosystem support for our Instinct GPUs. We architected ROCm to be modular and open source. This contrasts with CUDA, which is proprietary and closed. This makes AI development on AMD GPUs more accessible to more developers, startups, and researchers. So our foot is firmly on the gas pedal with driving the MI300 to volume production and our next ROCm release. So I'm really super excited that we'll be shipping ROCm 6 later this month. ROCm 6 has been optimized for Gen AI, particularly large language models, has powerful new features, library optimizations, expanded ecosystem support, and increases performance by factors. Now, I'm going to first walk you through the inference performance gains you'll see with some of these optimizations on ROCm 6. For instance, running a 70 billion Llama 2 model, page attention and other algorithms speed up the token generation by paging attention keys and values, delivering 2.6x higher performance. HipGraph allows processing to be defined in graphs rather than single operations, and that delivers a 1.4x speedup. Flash attention, which is widely used kernel for very high-performance LLL performance, delivers 1.3x speedup. All those optimizations together deliver an 8x speedup on the MI300X with ROCm 6 compared to the MI250 and ROCm 5. That's 8x performance in a single generation. So this is one of the huge benefits we provide to customers with this great performance improvement with the MI300X. Now let's look at it from a competitive perspective. Lisa had highlighted the performance of large models running on multiple GPUs. What I'm sharing here is how the performance of smaller models running on single GPUs, in this case, the 13 billion Llama 2 model. The MI300X and ROCm 6 together deliver 1.2x higher performance than the competition. So this is the reason why our customers and our partners are super excited about creating the next innovations in AI on the MI300X. And I'm really delighted to share some very late-breaking news. AMD GPUs, including the MI300, will be supported in the standard OpenAI Triton distribution, starting with the 3.0 release. We're really thrilled to be working with Philippe Tillet, who created Triton, and the whole OpenAI team. Innovators are advancing the state-of-the-art of AI on AMD GPUs today. ROCm 6 and the MI300X will drive an inflection point in developer adoption. I'm confident of that. Thank you.
Thank you, Victor. So that tells you a little bit about the ecosystem that we're putting together for MI300X. Now let me welcome to the stage Forrest Norrod to talk more about our AI networking and high-performance computing solutions.
Thank you, Lisa. Good morning. So far, we've talked about the amazing GPU and open software ecosystem that AMD is building to power generative AI systems. But there's a third element that's equally important to the performance and scalability of these large AI deployments, and that's networking. The compute required to train the most advanced models has increased by a factor of 50 billion over the past decade. Leading AI clusters are now tens of thousands of GPUs, and that's only going to increase. So the first way we've scaled to meet that demand is within the server. A typical server has perhaps a couple of high-performance x86 CPUs and perhaps 8 GPUs. You've seen that today. These are interconnected with a high-performance, low-latency, non-blocking local fabric. In the case of Nvidia, that's NVLink. For AMD, that's InfiniBand. Both have high signaling rates, low latency, both are coherent. Both have demonstrated the ability to offer near linear scaling performance as you increase the number of GPUs, and both have been proprietary, effectively only supported by the companies that created them. I'm pleased to say that today, AMD is changing that. We are extending access to the InfiniBand ecosystem to strategic partners and innovative companies across the industry. Doing so allows others to innovate around the AMD GPU ecosystem to the benefit of customers and the entire industry. When we're connecting thousands of nodes like we do in AI systems, the network is critical to overall performance. It has to deliver fast switching rates and very low latency. And in AMD, we believe it must also be open to allow innovation. Now, there are usually two networks connected to each of these GPU servers. A traditional Ethernet network used to connect the server to the rest of the data center, and more importantly, a backside network to interconnect the GPUs, allowing them to share parameters, results, activations, and coordinate in the overall training and inference task. Today, there are two options for the back-end fabric, InfiniBand or Ethernet. At AMD, we believe Ethernet is the right answer. It's a high-performance technology with leading signaling rates. It's scalable, offering the highest radix switching technology from leading vendors such as Broadcom, Cisco, and Marvell. And most of all, it's open. Open means companies can extend Ethernet, innovating on top as needed to solve new problems. We've seen the industry come together to create the Ultra Ethernet Consortium and Standard, where leaders across the field have united to drive the future of Ethernet and ensure it's the best high-performance interconnect for AI and HPC. Now, let's turn our focus to high-performance computing, the traditional realm of the world's largest systems. In 2021, we delivered the MI250, introducing third-generation Infinity architecture. That allowed the CPU and the GPU to share a coherent memory space and easily trade data back and forth, simplifying programming and speeding up processing. But today, we're taking that concept one step further, really to its logical conclusion, with the fourth-generation Infinity architecture bringing the CPU and the GPU together into one package, sharing a unified pool of memory. This is an APU, an accelerated processing unit, and I'm very proud to say that the industry's first data center APU for AI and HPC, the MI300A, began volume production earlier this quarter and is now being built into what we expect to be the world's highest performing system. Now, Lisa already showed you what our chiplet technologies make possible with the MI300X. The MI300A takes those same building blocks in a slightly different fashion. Now, the I/O die is laid down first, but with the MI300A, we also take CPU chiplets, leveraged directly from our fourth-generation EPYC CPUs, Genoa, and we put those on top of the IODs as well, thus bringing together our leading CPU, Zen, and CDNA technologies into one amazing part. Finally, 8 stacks of HBM3 with up to 128 gigs of capacity complete the MI300A. A key advantage of the APU is no longer needing to copy data from one processor to another, even through a coherent link. The second advantage is the ability to optimize power management between the CPU and the GPU. That means dynamically shifting power from one processor to another, depending on the needs of the workload, optimizing application performance. And let's talk about that performance. 61 teraflops of double precision floating point, FP64, 122 teraflops of single precision. Combined with that 128 gigabytes of HBM3 memory at 5.3 terabytes a second of bandwidth, the capabilities of the MI300A are impressive. When you look at the competition, MI300A has 1.6 times the memory capacity and bandwidth of Hopper. For low precision operations like FP16, the two are at parity in terms of computational performance. But where precision is needed, MI300A delivers 1.8 times the double and single precision FP64 and FP32 floating point performance. And beyond simple benchmarks, the real advantages of an APU come with the performance of real-world applications which have been tuned for the APU architecture. For example, let's look at OpenFOAM. OpenFOAM is a set of computational fluid dynamics codes widely used across research, academia, and industry. With MI300A, we see 4 times the performance of Hopper on common OpenFlow code. Now, that performance comes from several places. From higher performance math operations, as we talked, larger memory, and the increased memory bandwidth. But much of that uplift really comes from that unified memory eliminating the need to copy data around the system. That can perform for tuned applications truly transformative. And I'm also proud to say that beyond performance, AMD has stayed true to its heritage, to its history of leading in power efficiency. At the node level, the MI300A has twice the HPC performance per watt of the nearest competitor. Customers can thus fit more nodes into their overall facility power budget and better support their sustainability goals. AMD is proud of the leadership systems powered by MI300A, which will be available soon from partners around the world. I can't wait to see what researchers and scientists are going to do with these systems. And with that, I'd like to welcome Lisa back on stage. Thank you.
All right, thank you, Forrest. To cap off the day, let me now talk about another important area for AMD where we're delivering leadership AI solutions, and that's the PC. Now, for the PCs, we recognized several years ago that on-chip AI accelerators, or NPUs, would be very important for next-generation PCs. And the NPU is actually the compute engine that will enable us to reimagine what it means to build a truly intelligent and personal PC experience. We were actually the first company to integrate an NPU into an x86 processor when we launched Ryzen Mobile 7040 series earlier this year, and we integrated the XDNA architecture that actually came from our acquisition of Xilinx. Let me tell you a little bit about XDNA. It's a scalable and adaptive computing architecture. It's built around a large computing array that can efficiently transfer the massive amounts of data required for AI inference. And as a result, XDNA is both extremely performant and also very energy efficient. So you can run multiple AI workloads simultaneously in real time. Now, if you look at some of the applications, today Ryzen AI powers hundreds of different AI functions, things like advanced motion tracking and sharpening to deblur 4K video, enabling production-level digital production capabilities with unlimited virtual cameras, all in an ultra-thin notebook for the very first time. We're also working with key software leaders like Adobe and Blackmagic, and they're using our on-chip Radeon GPU to accelerate the AI-enabled editing features so that you can dramatically improve productivity for content creators. And of course, we've worked very closely with Microsoft to enable Windows 11 Studio Effects. They really capture the leadership performance that you can get from an NPU in Ryzen AI. Now, of course, we know developers always want more AI compute. So today, I'm very happy to say that we're launching our Hawk Point Ryzen 8040 series mobile processors. If you look at the top of the stack, so Ryzen 9 8945, it's actually significantly faster than the competition in many areas, delivering more performance for multi-threaded applications, 1.8x higher frame rates for games, and 1.4x faster performance across content creation applications. But when you look at the AI improvements of Ryzen 8040, you really see some substantial improvements. So things like Llama 2 7B, we run 1.4x faster, and also 1.4x faster on things like AI image recognition and object detection models. So all of this, what does it do? It provides faster response times and overall better experiences. Now, I really believe that we're actually at the beginning of this AI PC journey, and it's something that is really going to change the way we think about productivity at a personal level. So we've been working very closely with Microsoft to ensure that we're co-innovating across hardware and software to enable those next generation of AI PCs. We've showed you a lot of new products, a lot of new platforms, a lot of new technologies that are all about taking AI infrastructure to the next level. MI300X, MI300A accelerators, these are all shipping today in production. They're already being adopted by Microsoft, Oracle, Meta, Dell, HP Enterprise, Lenovo, Supermicro, and many others. You heard from Victor how we're expanding the ecosystem of AI developers, working with us, ROCm 6 software, the open ecosystem, that our goal is to make it incredibly easy for everyone to use Instinct GPUs. You heard from Forrest on the overall system architecture. We believe that to create this high-performance AI infrastructure, it has to be open, and that's what we're doing together for scale-out AI solutions. And then you heard what we're doing on the other side, the client part of our business, because we actually believe AI should be everywhere. So our latest Ryzen processors really extend our compute vision and our AI leadership. I hope you can see that AI is absolutely the #1 priority at AMD. Our goal is to push the envelope, to bring innovation to the market, because we believe, as wonderful as our technology is, it is about doing it together in a partner ecosystem where everybody brings their best to the market. I want to say on a personal level, today is an incredibly proud moment for AMD. If you think about all of the innovation, everything that we bring to the market, to be part of AI at this time, at the beginning of this era, to work with these amazing people throughout the industry, throughout the ecosystem at AMD, I can say that I've never seen something more exciting. A very special thank you to all of our partners who joined us today, and thank you all for joining us.